Australia up to the stage, and would you please give them a big round of applause? All right, sir. Yes, sir, yes, sir. And this is obviously forward and back. So I'm going to step down here, sir, and you take it away, and I'll wrap it up when you're done.
All right, thank you for that. As I was introduced, Geoff Mitchell, I'm the hands-on training program certified for ICAR Australia. We have a number of hands-on programs. We have the aluminium weld training certification, steel hands-on training certification, squeeze type resistant spot welding, and we also have a full frame welding introduction program which is under construction at the moment. I will cover that towards the end of this presentation. Just how the program evolved. Initially it was a verification program to assess and maintain skill levels within the post-trade arena of the industry. When we started delivering that, it became evident very quickly that we had an issue with welding skills in our industry. The pass rate was at 25%. We did get a little bit of bagging for that because it was so low, but it was definitely identifying an issue we had. ICAR Australia actually initiated a hands-on training program to run before that. So we put them through a training program to upskill them. It wasn't a case they couldn't weld, it was just that all the bad habits that they'd been allowed to get into over the years being unchecked. So with the introduction of the 4-hour hands-on training session, the pass rate went from the 25% up to 92% within about 6 months. So that's how we currently run it, and that hands-on training program, that's been picked up right across the ICAR platform in America, Canada and New Zealand. What we discovered, the equipment knowledge was a problem. Guys didn't know how to set their welding machines correctly. You'd see bits of masking tape on machines, advising people not to adjust the settings and what would happen if they did. Not a good look. Every weld that we do in our industry requires a different setting, whether it's vertical, overhead or flat. Eyesight's a major issue. We have people out there that are repairing these vehicles. They can't even see what they're doing. Around 70% of the people that turn up to these welding programs, we have to actually put magnification lenses into their helmets, whether it's just a 1.5 cheetah lens or even up to a +3 magnification. So those guys need to go straight down to the optometrist and get their eyes checked. You see repairs turning up in paint shops full of pin-ups. That's because guys can't see them because of their sight. If you have sight issues with welding, you cannot see through the flare, so you can't actually see what's happening to the puddle. And the other thing were just bad habits from people being left unchecked. Everything was just getting finger pulsed. And once they come to run on a thicker steel, it couldn't be done. And the other big thing is mild steel settings is what everyone has been trained on. We're now welding steels up to 1500 MPa, 500 MPa, dual phase steel. Mild steel settings will not work on those types of steel. They'll just lay the weld on top. I know this is about destructive testing, but I'll just quickly run through that. They need to go through visual testing and inspection prior to being destructively tested, and it's all about the identifying from the top of the weld what's happened behind it, because we can't see that when we repair a vehicle. So they're all assessed with an ICAR assessment card, all to AWS standards. So it's not a case of the ICAR trainer saying that weld doesn't fit the bill, or that's no good. They're all assessed and they must meet the criteria. One of the biggest things we look at for any of the visuals is the heat penetration into the back. The heat effect zone is critical because we can't afford to damage that metallurgical structure of the steel too much, and we need to leave around about 40% of it intact. So you'll see in that picture on the right, we only get a ripple through the back, which means we still have metallurgical structure intact. Plug weld visual inspections. How many people would think that a weld that's not correct will affect your airbag timing? So somebody's gone and welded on a chassis rail, front tie bar, crush cans. What's it going to do to the person in that chair if that weld lets go? When does a person hit the airbag? Inflating, inflated, or deflated? Does anyone want to answer that? So do they hit the airbag as it's coming out towards them, hit it when it's fully inflated, or do they hit it when it's actually on its way back down? Deflated is correct. If anyone hits an airbag while it's coming up, that's a broken neck, broken nose, broken cheekbones. You don't put the right weld in the right area, that's what's going to happen. Visual inspection on these plug welds, like I said, the one in the middle, that's the one that will get destructively tested. The other ones all have faults. The holes that you see in these plug welds visually, that is because there's no penetration into the base plate, into the panel it's being welded to. So the hot air trapped under the molten puddle is coming back out through the softest area of the weld. Even the one in the middle that looks superb with the divot in it, once we do a destructive test on that, we can find issues within the weld core itself. I had two guys just complete the aluminium program yesterday. They came and did the steel program a month ago, and their comment was, every plug weld they are doing now is getting the dimple on top of it. And that's to tell you that it has completely solidified correctly. I have some photos of destructively tested welds that I'll show you soon. Two types of destructive testing. The twist test, which we use on the plug welds. So when we do that, it needs to pull a nugget out of the base plate. If it fractures around the weld head or through the weld core itself, that's the fail on a destructive test. And the photo on the right there is of thicker steel. So that would be of our 3mm aluminium welding certification. And we also have the 3mm full frame program. All these welds visually look superb. That's the cut, polish and etch method. Sample A, you can see the weld itself comes out a different colour when we etch it, and that's just sitting on top. So when we do a destructive test, that just tears off the base plate. Sample B, most people will really like the penetration on that weld coming out the back side of it, but that's where our fracture point is, along the edge of that weld. That's because there's no metallurgical structure left intact around that weld area. And sample C there, 30 to 50% burn into the base plate is what correct penetration is when we're welding. So these images here, these are plug welds that have been destructively tested by using the twist method. As you can see, it's a little bit like honeycomb. That weld has been filled too quickly, too cold. It hasn't given the molten material time to solidify correctly, and you can even see the 8mm hole that it was plug welded through. So incorrect wire diameter. I actually went to a shop one day to do some training, and their plug welds, we were just breaking them by hand. They'd used 0.9 wire in their machine for the last 2 years because they couldn't stop the 0.6 or 0.8 wire bird nesting. What was happening, they were filling the plug welds that fast, it wasn't having time to burn into the base plate or fuse the edges of the hole. They had no strength at all. It's a bit of an eye-opener for that shop. They were a little bit concerned after that. So we need to make sure we're using the correct wire diameter to start with. Incorrect machine settings. If you don't have your amps or your voltage high enough, it won't melt the filler wire correctly, and it will not burn into the thicker steel. With the tighter metallurgical structure of the steel, you need the heat to burn into the base plate. The last dot point there, arc length or voltage. I got asked to go to a shop who was having issues with plug welding. They were actually doing practice welds, which was good. And they couldn't get the plug welds to get any strength. They were putting a chassis rail on a Subaru. And they asked me if I could call in. When I walked in and looked at the welding machine, You have the metal thickness dial and you have the arc length dial. It touched the arc length dial, which is a background setting, and it was wound down to the maximum low setting. So all it was doing was boring the molten filler on top. So again, not knowing your equipment, knowing what arc length to use, all our welds should be on around about 17 volts. Guys are now doing plug welds at around 80 amps, where most of them used to do it around 30 amps. Another one, this is where they've started the plug weld in the wrong location. So they've welded around the edge and then gone to fill the middle of the hole. Unfortunately, that's how the industry has been taught to do plug welds on mild steel. It won't work on high strength steel. Spot welding destructive testing. Mike mentioned about the OEMs and what they're saying on spot welding, their warnings, things like that. A lot of OEMs actually have a warning on 3mm stack for plug welding, where you have to turn your automatic settings off and do manual settings. Same with anything over 600 MPa in strength. A lot of this comes down to what power supply is available at workshops, and then you add extension leads, which drain more power out of what the spot welding machine can handle. We've got 16,000 amp spot welding machines, but we've got spray booths, compressors, prep areas, and then you try and throw a 60,000 amp spot weld in place, and it's got to draw power from everything else in the building. So we need to make sure the workshops have enough power supply. I mentioned we had a full frame program in construction. We currently already deliver a full frame program for Holden Australia. Mike, I just wanted to, you mentioned about practice coupons. Holden Australia for Colorado, they actually supply a part number kit of the correct material. So they're sort of ahead of it all at the moment, which is really good. So yeah, with these full frame vehicles, we now have 3mm thick steel, 320 to 580 MPa, but it doesn't stop there. We have dual phase, trip steel, and high strength steel. We have the hydroformed 700 to 800 MPa chassis. We can't weld them the same as what we weld paddle steel. The base metal is harder to weld into. The settings need to be much higher, and your travel direction has to be different. And our smash repair industry's had no formal training on that. All our panel beaters have been trained to finger pulse quarter panels. Then they apply it to chassis, full frame chassis, plug welds. That's where our issue starts. You'll see on the right hand picture there, that weld has just snapped straight off the base metal, no penetration whatsoever. And that's done at around about 130 amps. The picture on the left is how it was meant to test up when you do a destructive test. It bends all the steel around it and doesn't fracture through the weld. This is what's going to have catastrophic results in another collision and start hurting people, killing people. That we need to take into account, and we need to have that formal training on anything that we're looking to do ahead of the game. There's no point getting that car into the workshop and then learning to do it. You need to know how to do it prior. That pretty much wraps me up, Mike. SAPE, being a supporter of us, we use their venue in Sydney for our welding programs, and always handy with equipment. That's it.
Appreciate that. So Holden has a part number that you can make available to people, is that correct? Thank you, sir. All right. So I wanted to, and I'm done with that session a little early because I want to be able to have plenty of time for the next session. Any questions on this? Anything you agree with, you disagree with? I would love some dialogue. Anything from anyone at all? Any questions? Yes, ma'am. I don't disagree with you at all on that, ma'am. I would be terrified as well. It's very concerning. So at the end of the day, like, we know there's an issue here, so what's the solution? And the solution is we have to have dialogue, we have to start talking, right? Without fear of retribution and just being honest, transparent. But I would agree with you on that, ma'am. Questions, comments from anyone? Yes, sir, in the back.
Huh?
Yes,
Should the insurance companies be saying to the repairers that they have to do the destructive welds before they repair the car?
If you're asking me my
Should they be
opinion,
insisting?
I would say, first of all, if I'm an OEM manufacturer and certifies a shop, I would insist on them doing it. If I was an insurer and somebody was doing work for me, I would insist on that as well. So, but regardless of that, a shop needs to do it. But yes, I believe that yes, you should. Yes. Absolutely. Because here's the deal, right? I don't know what it costs in Australia, but the average fatality in the US ends up costing an insurance company between 1.2 and 3.7 million dollars. So what's the price of a life? Yes, sir.
Sorry, Mike.
Please.
Answering that question about insurance companies asking for destructive tests, there are insurance companies that are requesting it here now.
Great. Other questions, comments? Well, I hope that between myself and the gentleman from iCar that somehow we've encouraged you today or create awareness enough that you'll at least start thinking about it or desire to do it, right? And not just go through the motions, but do it properly. So please give my new friend from iCar in Australia another very big round of applause.